Welcome back, students. Today I'm going to discuss about properties of sliding contact bearing. So before going to start sliding contact bearing, properties of sliding contact bearing, you better go through the previous videos and study the sliding contact bearing, which I was explained with examples. So without knowing what is sliding contact bearing, you cannot understand the properties or further concepts regarding to the sliding contact bearings. So let me start with the properties. So these are some important properties are required to use the sliding contact bearing. Number one is compressive strength. So this is the most important property. That means the maximum bearing pressure is considerably greater than the average pressure obtained by the load aided to the projected area. That means we have a lesser space, a lesser area inside, but the load acted on is more while compared to average pressure. So that means the wedge action is, while wedge action is created, the pressure developed in the bearing is much more. So our material should overcome that kind of stresses. So must have a good compressive strength. Therefore, the bearing material should have high compressive strength to withstand the maximum pressure, so that to prevent the extrusion or other permanent deformation of the bearings. And coming to next one, fatigue strength. So the bearing material should have a significant fatigue strength that can withstand the repeated load without developing any fatigue cracks. That means it can withstand the repeatedly applied loads. So the major importance in the aircraft and automotive industries, we must use a better suitable bearing which have much fatigue strength. And next important one, conformability. It is an ability of the material to accommodate the sharp deflections and bearing inaccuracies by plastic deformation. That means a creep without any excessive wear and tear and heating. So that is the most important, conformability. So coming to next important property, fourth one, embeddability. So embeddability is the one of the major part to uh, that means it should be short out, right? It's short out from the other materials. Like, it is the ability of the material to accommodate or embedded with the small particles. That means it should not mix together like dust, grit, without scoring the materials of the material journal. Next one, bondability. The many have high capacitive bearings are made of the bonding or mere thin layers of the bearing materials to high strength steel shell. So the steel shell must be very high strength, and it have the good bondability, a good strength of bond with the surrounding material. That means, so bondability is an important consideration to select the suitable bearing to create suitable bond. It should not mix the oil and the material, and it should not mix with the dirt and drift. So the bondability which created by them to create the particular clearance, it should have minimum clearance. That is nothing but the bondability and embeddability, difference between a bondability embeddability between a material and the fluids. So layers must be formed with good bondability. That is the most important point to understand. Next important one property is corrosive resistance. So you know that it is a completely that means occupied with a lubrication oil. That oil should not be erode the material. This property is the particular importance to internal combustion engines, where the small oil is used to lubricate the cylinder walls and the bearings. In the cylinder, the lubrication oil comes into the contact with the hot cylinder walls, and it may be oxidized and collect a carbon deposits from the wall that causes the corrosion, that causes the clogging effect. So our material should have less corrosions, and it have a good corrosive resistant power. The thermal conductivity, next property. The thermal conductivity of the bearing material should be high, so that it prevents the rapid removal it provides a rapid removal of heat generation by the friction, and maintain the uniform temperature of the material. the thermal expansion. The material, bearing material should have low coefficient of thermal expansion. That means the dimension should not be changed due to the temperature change. It should not be expand. The dimension should not be changed. The proper clearance must be provided. If the material is reacted with the temperature, if it is expand, what will happen? The clearance might be reduced. That causes metal to metal contact, which creates a lot of dust, sound and noise, as well as wear and tear. So that is not acceptable for any bearing material. So thermal expansion should be very low. Therefore, no change in clearance happens. Okay. So that is the important properties of the materials for any bearing surfaces. Next important and properties of metallic bearing materials. See, here we have different type of bearing materials are available. These are the materials we are going to use for the bearing. And if you use the material, these are the properties we have for the particular material. For example, if you use a tin based material, the fatigue strength is very low, you know, but it have good conformability, excellent embodiability, anti-scoring, corrosion resistance, everything is fine, but thermal conductivity is poor. So the application is very important, so if I use in an automobile, the thermal generation, heat generation is more, so thin based babbitt materials is not suitable for that, right? So coming to lead based one, the fatigue strength is again poor, but remaining conformability, embeddability, anti-scoring, corrosion resistance, everything is fine, but again thermal conductivity is poor. So coming to lead bronze, it's everything is fine, but conformability, embeddability, anti-scoring is poor, remaining are good. So we need to sacrifice some properties. So no material cannot give 100% efficiency. So you need to compromise regarding to the application. So depends upon the properties exhibited by the material. You need to select the suitable type of the material for the particular bearing according to the application. So not only that, for example, you see in the silver or silver lead deposit, it have an excellent fatigue strength, excellent conformability, but embeddability is low, but anti-scoring, corrosion resistant, thermal conductivity, everything is fine, but the cost of the material is very high because it is silver lead based material. If you want the less weight, you can go for aluminum, but it is have again some disadvantage or limitations, that nothing but there is less conformability and embeddability, and remaining else are good. So majority of the materials or majority of the bearings are aluminum based and lead based, copper based alloys. That is the reason behind to select a suitable bearing according to the requirement. So this table is useful for you to select the suitable type of the bearing according to our requirement. Thank you. And coming to next point, lubricants. The inside the bearing and the journal, the lubricant is very, very important. That's very, very, very important. So where the lubricant may be present, I will explain with the figure. See, this is the outside base. This is bearing. This inner shaft, nothing but journal. In between we have a blue color area, is nothing but a space to pour lubrication oil. So in this space we are going to pour our lubrication oil. So this oil can maintain minimum clearance between them. So this oil is occupied in between journal and the bearing, which shows in a blue color, so which avoids the metal to metal contact. So what kind of oil is suitable to pour between these two elements? What properties must have for a lubricant? You must have to know before going to pour in it. So let us go through it. So coming to the lubricants. So lubricants are used in the bearings to reduce the friction between the rubbing surfaces and to carry away the heat generation by the friction. We know that. It is also protects the bearing against the corrosion. All the lubricants are classified into mainly three categories. Number one, liquids. Liquids are nothing but mineral oils or synthetic oils. Second one, semi-fluids or semi-liquids, like grease of high viscosity, use very high pressure and low velocity existed. Next one, solid like graphite powder. Graphite material have good frictional resistance where no oil film will be generated, but zero film lubrication may be possible, but it is not suitable. It can maintain pressure and temperature, but it is not suitable to noiseless operation. So according to our requirement, we are going to choose three different type of lubricants according to our requirements. So liquids and the synthetic oils are generally used where we have a hydrodynamic lubrication. Semi-liquid or we can use thin film lubrication, but solid graphite lubricant can use for zero film lubrication. This is the requirement, and according to the requirement you can choose your lubricant. So coming to the next one, very important one, terms used in hydrodynamic bearing. So this is very important, guys. This is the key part of the unit. So let us see this figure. In this figure you can see a two different centers, right? See, this is one center, this is one center, and this is another center. See, yellow color center is nothing but bearing center, pink color center is nothing but journal center. So these are not in line, so these are not a concentric circles. You know, concentric circle have same center, but these are not two concentric circles. It have some distance. That distance is nothing but we can represent it as E is nothing but eccentricity. So there is a distance between them, and load is acted only on shaft, not on the bearing. Okay, bearing only gives support, but the load is acted on the shaft. That load is distributed through oil. So this oil throughout the body, the load is received by the oil and distributed throughout the body. So automatically load is distributed to bearing. So the oil is responsible to carry the load cell. So it also provides the lubrication effect. Also it provides some uh, then that means distribution of pressure also possible using this oil. And coming to capital R, capital R is nothing but radius of the bearing, and coming to small r is nothing but radius of the journal. H naught is nothing but minimum oil film thickness, and line of centers, if you join the two centers in line you will get the line of centers. This is, it might be changed, while in a rest condition the line of centers may be in second quadrant, but if the velocity is increased in a high speed, the line of centers may be distribute, it changes to quadrant, third quadrant I think. So depends upon the speed of the journal, depends upon the rotation clockwise or anti-clockwise, the line of centers may be changed. So let us go through briefly about the terms we must use in journal bearing. Right. Number one, a hydrodynamic journal bearing is shown in the figure. I already told you the O is the center is nothing but journal. O dash is center for the bearing. Let capital D is the diameter of the bearing, and small d is diameter of the journal. Small l is the length of the bearing. The following terms used in hydrodynamic bearing throughout the unit. So if we have capital D, you must assume that is diameter of the bearing. Small d, diameter of the journal. Small l, nothing but length of the bearing. So this is the important one you must remember. Terms. First term, diametral clearance. This is very important, guys. Diametral clearance. It is the difference between the diameter of the bearing, diameter of the journal. That's it. Difference between the two diameters. Whereas radial clearance, difference between the two radius, like journal radius and bearing radius and journal radius. Difference between bearing those two radius. It is denoted by C1, where a diameter clearance is denoted by C. Coming to diametral clearance ratio, it is the ratio of the diametral clearance of the diameter of the journal, right? So it is the ratio of C by D, where C is equal to capital D minus small d by small d. So D minus D by D. So you can write like this. So D minus D minus 1 you can write like this. So that is diametral clearance. Next important term, eccentricity. It is the distance of radial distance between the two centers. You know that. It is denoted by small e. Minimum oil film thickness, that is H naught. It is the minimum distance between the bearing and the journal under the complete lubrication condition. It is denoted by H naught and occurs at the line of centers as shown in figure. It is the value may be assumed as C by 4. So remember it. See in this figure, this is nothing but H naught. H naught is nothing but minimum oil film thickness. You know, here we have larger distance. So due to the convergency, the distance might be decreased. At a particular position, we will get very less. That lesser distance is nothing but minimum oil film thickness. It is possible when the lubrication oil is presented in between them, right? That is minimum oil film thickness. Next one, uh, attitude or eccentricity ratio. It is the ratio of eccentricity to the radial clearance. So E by C1. Radial clearance means C1. It is not diametral clearance. Diametral C1 clearance is C, but radial clearance is C1. So E by C1. So you can write E is equal to C1 minus H naught. You can write like this, because how it will be like this means, in this figure you can see here to here the distance is small r plus H naught, right? Small r plus H naught. So if you remove small r plus H naught means I can explain like this. You can see that from here to here, I can say that this is C1, right, is equal to E. So that is C1 is equal to C1 and R minus is nothing but capital R minus small r, right? So here it is capital R minus small r. So we have some space. That space is nothing but H naught, right? Plus we have eccentricity, distance between the two centers is nothing but E. So which is equal to this. So this is the condition you need to maintain for perfect clearance. This is the condition you need to understand to maintain perfect clearance. From this you can say what is E is equal to C1 minus H naught, right? That is eccentricity value you have to remember, right? So coming to the terms again. So already told you that this is eccentricity E is equal to C1 minus H naught and divided by C1. So I can write 1 minus H naught by C1. I can write like this also, 1 minus 2 in H naught by C, because C1 is equal to 2C, right? Sorry, C by 2. Sorry guys, C1 is equal to C by 2. So you can write like this. So next one is short bearing, long bearing, square bearing. It's very important. Short, long. If the ratio of the length of the diameter of the journal, that is L by D, is less than 1, it is nothing but short bearing. So if L by D ratio is less than 1, it is short bearing. If L by D ratio is greater than 1, it is long bearing. If L by D is equal to 1, that is nothing but square bearing. So that is the most important terms is to be remember for continuing the next class. In the next class, I will start design procedure to solve any journal bearing. So don't miss it and please cooperate with us. Thank you.